Yeah, hi everyone. So today we're going to discuss a little bit on the Shmoo plots. So as you know, the Shmoo plots we are generally used, when we have to do the debugging. Okay. So when we release the patterns to the tester team. Okay. So they would be trying it out on the tester, on the patterns on the tester, and then they would be sharing the tester logs with us. Those tester logs, we would be analyzing it based on the different PVT condition. We would be running the scan diagnosis on that. So to run the scan diagnosis, Shmoo plots are very much beneficial because it will help us out to do the debugging. So what are the Shmoo plots? So first we just need to understand a little bit more on this. What are the Shmoo plots? So Shmoo plots play a vital role in the debugging. And here we are playing with actually three variables. One is called the frequency, another is called the voltage, and the third one is called the temperature. So we would be drawing the Shmoo plots against the three independent variables: frequency, voltage, and temperatures. Why we require it? We require it extensively for the debugging purpose. And these Shmoo plots are helpful to nail down the electric failures in the circuit under test. The patterns what we are going to provide as a DFT engineer to the tester engineer, they would be tried out with the different process conditions, with the different variations of the voltages and frequencies, and then the results are being sent to the DFT engineers in the form of the Shmoo plots, which we will be analyzing, and we would be drawing or plotting the Shmoo plots as well if we are running the patterns on the tester when we are trying the cloud testing station, and then just try to find out what is the root cause. Okay, so there are the different kinds of the Shmoo plot. So this is a small video which will just give you a glimpse of the classification of the Shmoo plots. What are the different kinds of Shmoo plots and what they actually indicate. So as I mentioned that right now we are just discussing the classification of the Shmoo plots. So there are the many kinds of Shmoo plots. So the first Shmoo plots what we are seeing here, it's called the normal Shmoo plots. So it is a well-behaved Shmoo, and here you can see that this particular Shmoo is plotted against voltage and frequency. So you can see when we are moving towards the x-axis, frequencies get increasing, and then you can see the design is actually working at higher frequency, but when you are going when you are going beyond the limit, then you can see some red region over there. So similarly we can see when we are moving upwards in the y-axis, the voltage is increasing. So green portion, what does it indicate? So green portion is indicating that it is a pass region, and the red portion is indicating that it is a fail region. So this is a very important Shmoo, and while doing the debugging, when you are trying to draw, the Shmoo plot, so this is the major, very popular Shmoo, which actually indicates that how the design is working, whether the design is passing in the high frequency region or it is failing. So it is a very good indication, okay, when you are drawing this particular Shmoo. Okay, let's discuss another Shmoo plot. This we call it as a brick wall Shmoo, and you can see the brick kind of slices over there. Okay, so this brick wall Shmoo, what does it indicate? So it depicts the bistable initialization problem of the chip. So this occurs mainly if either first or the second time, the initialization goes randomly. For example, a register without a reset value defined for it may take 0 or 1 for initialization. For example, if you have any scan register, and that particular register, if it is not initialized properly by means in if that register is not having the proper reset value 0 or 1, so what can happen when you are running in the first time? It may take the 0 value or it may take the 1 value, so the unknown value would be there. Okay, so it may not pass in the first time, but maybe in the second time it is going to pass because it would be holding the right value at that time. Okay, so the device may fail at first, but it may get passed when you are testing it for the second time. So it seems to be a problem. There are many registers, which have the initialization issue. Okay. Okay, so this is called the Brickwall Shmoo. Okay, so if you are seeing this kind of Shmoo, if the tester engineer sharing this kind of Shmoo with you, then you can immediately check whether the initialization could be a problem. Okay. Okay, so this is the third, whatever the classification we are discussing. So this is the third class of Shmoo. So this is the third kind of a plot. So we call it as a wall Shmoo. So what Walsh-Shmoo is going to indicate? So it is going to depict a failure at a certain voltage, irrespective of any variation in frequency. So you can see in the x-axis we have the voltage percentage, in the y-axis we have the frequency. So after a certain voltages, irrespective of the fact that the frequency variation is happening in the x-axis, you can see only the red regions. It means the voltage is always failing. Okay, means the device is always failing, okay, at a certain voltage irrespective of the change of the frequency. So why this kind of problem actually happens? So this kind of Shmoo actually indicates that there is a problem of the noise coupling, race conditions, and charge sharing. Okay, and this noise, what we are calling it as a noise, it can be aggravated by di by dt, that is a high inductance, and dv by dt, that is a high capacitive coupling. So coupling could be an issue. And higher voltages, what does it indicate? It indicates that circuit is going to work faster, and which can lead to the hold violation, that is latching data at incorrect time. And the failures because of noise may also occur at very low temperature as well as very high temperature, depending upon the circuitry. So if the tester engineer is going to give you a kind of a Shmoo, which actually when you are just looking at it, and if you feel that it is a wall Shmoo, then you can just expect some problems, and the problems could be noise coupling or the race conditions or charge sharing. Okay, so these kind of problems can be there, okay, in the device. Okay, now we are going to discuss something about the reverse speed path Shmoo plots. So reverse speed path Shmoo indicates a leakage of the weak nodes before the end of the cycle. So you can see an staircase kind of a thing, and it's called a speed path. So here how the plotting is happening. So it depicts the Shmoo plot of how the circuit behaves with significant RC delay. If the voltage is higher, then the leakage would also be the more, would also be more. Okay, so this is a Shmoo plot which actually indicate the leakage of weak nodes. So if that kind of Shmoo plot is there and is being shared by the test engineer, so it indicates that there's a leakage of the weak nodes before the end of the cycle. Okay. Now this is the floor Shmoo. So here you can see at the lower frequency node, okay, the circuit is not working. You can see some brown or yellow region, but at the higher frequency range, you can see the green region. The circuit is working perfectly fine. Okay, so this is kind of a floor Shmoo where the circuit is working at a higher frequency, but at the lower frequency there's a problem. And what does it indicate? It indicates that it is a variant of leakage problem. There might be leakage problem irrespective of the voltage variation. You can see the voltage is varying, okay, but in the high frequency only the circuit is working, but in the lower frequency, okay, in the lower frequency range, okay, the circuit is not working. Okay, so the voltage variation is not a problem here. In the lower frequency node, the circuit is not working. So at lower frequency, when the leakage is present and no other circuitry is active, circuit gets enough time to leak. So that is the reason. So at the lower frequency, what's going to happen? The leakage is also present and the circuitry is not very much active, okay, because the switching is not happening that much. So here, the circuit gets enough time to leak. For higher temperature, the temperature is going to be increased. The leakage becomes more prone as heat increases sub-threshold leakage in um, transistors. Okay, so when you are increasing the temperatures, then because of the heat, the leakage is also going to increase. Okay, so this is kind of a floor Shmoo. The last Shmoo what we are going to discuss, it's called the finger Shmoo. Here you can see the finger, small finger kind of arrangement. The large area of our Shumo plot is green, but you can see slight failures in the form of some small bricks, and we call it a finger Shumo. So finger Shumo, what does it indicate? It represents the inductive or capacitive coupling issues. It indicates a problem in the alignment of the aggressor and victim, where at a specific frequency and alignment it also causes the failure. So whenever the finger Shumo plot is there, then there's a problem. There would be a problem in the alignment of aggressor and victim. Okay, where at a specific frequency and alignment it also causes the failure. So this is a finger Shumo. So here I'm just going to tell you something of the whole circuitry. What are the what are the problems associated with it, with reference to the temperature and other stuff. So when the temperature is going to increase, the transistor performance is going to get affected, and as the results, what's going to happen? The resistance is going to increase, which lead to the low frequency of operation. Same way, when the temperature is going to decrease, the transistor performance is going to improve, and hence the resistance as well as the leakage is also going to decrease. Okay, so these things you need to keep in mind. Where like when we are going to increase the temperature, the transistor performance, how it's going to get affected, because the resistance going to increase, and which will try to impact the frequency of operation, and it would be working in the low frequency. Similarly, when you are going to decrease the temperature, the transistor improvements, the performance is going to improve, and the resistance is going to be decreased, and the leakage is also going to be decreased. So thus we should understand that the temperature plays a vital role in testing. Henceforth, the circuit should be tested in simulation at all the process corner: fast, slow, and typical. It should be shumoed at different frequency, voltage, and frequencies. Okay, so this is a small video in which I have just explained, the importance of the Shumo plot and the classification of the different Shumo plots, why Shumo plots are necessary, and what are the different Shumo plots we can plot. Okay, and what kind of problems are associated with the different Shumo plots. So when you are going to get some Shumo plots from the tester team, if you are working on the tester, and when you are trying to draw these plots, does these plot indicates? Okay, what are the different problems associated with them when you are going to analyze those plots? So this kind of overview I just wanted to give you with this particular video. Thanks a lot.